Imagine this. Right now, somewhere in an absolutely infinite void of shifting probability, there might just be a brain floating completely alone in the dark. It has no body, no eyes, and no actual universe around it. But it has just finished having the exact same thought you are having right this second. Stick with me here because things are about to get really, really strange.
Welcome to The Explainer. Today, we are counting down 10 of the absolute most mind-bending scientific and mathematical paradoxes ever discovered. And look, these aren't just weird little quirks of arithmetic. We're talking about fundamental, reality-breaking fractures in how we understand time, memory, and the entire cosmos.
Honestly, by the time we hit number 1 on this list, you're going to seriously question whether the ship you're sailing through life on is even the same ship you started with. You'll wonder if the sheer size of the universe means you were never really free to choose your own birthday, and whether the universe itself is just quietly running out the clock on everything that has ever existed. So buckle up, because number 10 is where the nightmare starts.
All right, let's dive right into it. Number 10, the Boltzmann brain problem. I want you to picture the universe as this infinitely large casino that never closes and literally never runs out of chips. Given enough time, that cosmic casino is going to deal every possible hand over and over forever.
Now, physicists realized something deeply creepy when they looked at entropy, the universe's tendency to get messier over long stretches of time. In a universe that's old enough and big enough, pure random fluctuations in that chaos could, just by accident, briefly assemble a fully functioning, self-aware brain floating in empty space. It would even have fake memories of a life it never actually lived. And mathematically, it's statistically way more likely for a random fluctuation to create one lonely floating brain with fake memories than it is to create our entire orderly universe with billions of years of real history. So statistically speaking, you're far more likely to be a hallucinating Boltzmann brain right now than a real person sitting in a real chair. Now, scientists don't actually believe that's happening, but they use it as an alarm bell. If your physics theory predicts that you're probably a floating brain, well, you messed up the math somewhere. But it's crazy that serious physicists have to literally prove they aren't floating brains.
Moving on to number 9. The grandfather paradox. We've all heard this one. Say scientists finally crack time travel, and you go back and accidentally prevent your grandparents from meeting. Well, no meeting means no parents. No parents means you were never born. But wait, if you were never born, you never existed to travel back in time to stop them, which means they did meet, you were born, and you did go back. It's a loop that just eats its own tail forever, and it instantly gives physicists a massive headache.
The really big problem here is that the math of general relativity doesn't actually forbid these time loops outright. So how does the universe protect itself from breaking? Enter reality's bouncer, the Novikov self-consistency principle. This basically says the universe simply will not allow a paradox to happen, period. Your car breaks down, you trip on the sidewalk, you get talked out of it. The cosmic bouncer makes sure nothing paradoxical gets through the door. Other physicists think it's more about parallel timelines, where your interference just branches reality off into a totally new separate path.
Next up, number 8, Zeno's paradox. This is a classic ancient Greek trick that logically proves motion is totally impossible, even while you were sitting there moving around. So 2,500 years ago, this guy Zeno imagined a race between the mythical hero Achilles and a super slow tortoise. Achilles gives the tortoise a head start. By the time Achilles runs to where the tortoise started, the tortoise has shuffled slightly ahead. Achilles closes that new, smaller gap, but the tortoise has moved forward a tiny bit again. This just keeps happening forever, an infinite number of steps. Zeno's trap says, hey, if you have to complete an infinite number of steps to go anywhere, you can literally never finish moving.
But obviously, in real life, Achilles just blows right past the tortoise. That disconnect drove mathematicians absolutely crazy for thousands of years. It actually took the invention of calculus and the whole concept of infinite series to finally prove that yes, you can add up an infinite number of shrinking distances and still just get a normal, finite number. The fact that infinity could actually be tamed, that took some of the smartest minds in history 2 millennia to finally nail down. And speaking of infinity messing with our heads, let's look at number 7, the Banach-Tarski paradox. This one is basically mathematical alchemy, and it feels like it shouldn't be allowed to exist in our reality.
So, according to accepted mathematical rules, specifically something called the axiom of choice, it is theoretically possible to take a solid ball, cut it up into a handful of oddly shaped pieces, and then reassemble them into 2 solid balls, each the exact same size as the original. There's no stretching, no adding new material. You just literally double the volume out of nowhere. Sounds like a magic trick, right?
The catch is that these pieces have to be infinitely jagged, non-measurable clouds of points that only exist in pure math. You can't actually do this with physical atoms in the real world. But it perfectly proves that infinity does not play by the rules of our ordinary, countable universe.
All right, number 6, the fine-tuned universe. Imagine walking into a hotel room and finding the thermostat, the lighting, and even the mattress firmness dialed into your exact, highly specific personal preferences purely by chance. That is our universe.
If you nudged just a handful of the universe's fundamental settings by the absolute tiniest fraction, the whole thing falls apart. Make gravity just a tiny bit stronger, stars burn out in a flash. Slightly weaker, you get a cold, dark void with nothing in it. The force holding atomic nuclei together is tuned so perfectly that if you changed it by a fraction of a percent, stars couldn't produce carbon. And carbon is literally the backbone of all living things, including you. This leads scientists to a huge debate. Do we just live in a massive multiverse where our universe won the cosmic lottery? Or is there some deeper, undiscovered law of physics that forces these numbers to be exactly what they are?
That brings us to number 5, which breaks people's brains in a totally different way: the simulation hypothesis. Think about how incredibly fast video games have evolved. We went from flat, blocky pixels to VR headsets that literally trick your inner ear in just a few decades. Now stretch that curve forward thousands of years. At some point, humanity is going to be able to simulate an entire universe full of trillions of conscious beings who are completely convinced that they are real.
The statistical logic here is what's really terrifying. If even one advanced civilization out there builds a simulator capable of running billions of universes, then simulated conscious minds would massively outnumber the original biological ones. So, the odds of you, personally, being one of the rare biological minds, rather than a simulated one in a giant computer, incredibly small. Physicists are taking this so seriously that they are actually looking for literal glitches in cosmic ray data, sort of like how video games render distant scenery with less detail to save memory.
So, from glitches in the universe to glitches in your own mind, here's number 4, the Mandela effect. Do you remember a famous cartoon character wearing a monocle, or maybe a specific hyphen in a famous brand logo? Well, they never actually existed. Entire communities of totally unrelated strangers often share the exact same, highly detailed but completely false memories.
Psychologists explain this through something called confabulation. See, your brain doesn't actually store memories like a video file on a hard drive. It just stores little fragments. Every single time you try to recall something, your brain rebuilds the scene completely fresh, and it quietly fills in the gaps with assumptions and expectations without ever telling you it's doing it. You aren't remembering the original event at all. You are just reconstructing your last reconstruction. That means the version of your childhood playing in your head right now has been secretly edited, and you have absolutely no way of knowing what was changed.
Getting down to the top 3 now. Number 3, the quantum Zeno effect. We've all heard the old proverb, right? A watched pot never boils. Well, in the extremely weird world of quantum mechanics, this is literally, physically true. Unstable particles generally decay totally randomly, kind of like a kernel of popcorn popping in a microwave. But if physicists measure an unstable quantum system frequently enough, they can actually freeze its decay. It's kind of like a nervous parent hovering over a toddler who's about to touch a hot stove. If you catch the motion early and often enough, the action never actually completes. Rapid, repeated observation physically suppresses a natural quantum transition, essentially hitting the pause button on time for that particle. It proves that simply paying attention to something literally changes how it behaves at the very foundation of reality.
Okay, number 2. Here we find a mind-bending illusion hidden right in everyday life, the birthday paradox. If you are standing in a room with just 23 people, what do you think the odds are that 2 people in that room share the exact same birthday? Your gut probably tells you the odds are terribly low, right?
Our instincts are completely wrong on this one. With just 23 people, there is actually a better than 50% chance of a shared birthday. It's a coin toss. Bump that group up to 70 people, and it's over 99.9%. The trick your brain misses is that you aren't just comparing everyone to your own birthday. You are comparing every possible pair of people against each other. With 23 people, there are actually 253 unique pairs quietly checking each other's birthdays behind the scenes. Stack enough small chances together, and the odds just shoot through the roof. This math is so incredibly robust, it's literally used today by cryptographers to secure modern digital systems.
And finally, we reached number 1, the heat death of the universe.
This is the quiet, slow-motion ending of everything, and it is already in progress right now, whether you can feel it or not.
Every single process in existence, stars burning, planets spinning, even your own heart beating, runs on usable energy flowing from hot to cold. And every single time that happens, a little bit of that energy becomes permanently unusable, spreading out into low-grade, useless heat. That's entropy, and it never reverses, not ever. Stars are not an infinite battery. Long after the last star burns out and the very last black hole evaporates into nothing, the universe is going to settle into a state of maximum entropy.
There will be absolutely no usable energy left to power anything. No stars, no light, no motion, no thought. Time itself will basically cease to mean anything because nothing will ever change again. It's not some dramatic, fiery apocalypse. It is just an infinite, permanent, unchanging stillness. Every clock, every star, and every heartbeat is technically counting down toward this total stillness, one tick at a time, right now, while you are watching this explainer.
So the next time you're sitting there feeling like your day was a total waste, just remember that the entire universe is doing the exact same thing, just on a scale so massive it makes your whole lifetime look like a single blink. And yet, against the Boltzmann brains, the infinite paradoxes, and the dying stars, you exist anyway. Right here, right now, thinking about all of it. So what does that count for? Thanks for joining me on this explainer. Keep wondering about the weirdness of it all, and I'll catch you next time.